Welcome, welcome to the pre-recording of lecture 17, session 9 of this 8-week summer course in the beginning of the 4th week. This is the first half of this session 9 labeled as lecture 17. We will see how to work with files in Python. We started this in the last lecture. But because files are so important, and also there are many standard algorithms that we need to practice, we will devote one entire lecture on working with files. It may seem at first a little bit tedious and repetitive, but once we understand very well how to work with files, we can also look at files on the internet. We can retrieve data from the internet without using a browser, as I will explain in the sequel lecture or in the second part of the session. So data store information permanently, and we are living in the time of a data explosion. So even if our disks are getting larger and larger, and if there is the cloud, there is always the need for compression. We distinguish between lossless compression and lossy compression. Lossy compression we will not treat, but you could think of images, for example. If you have a high resolution image, then you may as well do just as well with a lower resolution image. So you have some errors there. In lossless compression, you do not tolerate loss of information. You can still make your files shorter by using dictionary encodings. So for example, any English text will have multiple occurrences, many occurrences of the word the, and you could replace all the these by a symbol and then use a dictionary to use this encoding. So that is the idea behind a very popular encoding, a very popular compression algorithm used in GZIP. So this lecture, this introduction to computer science is not intended to discuss more advanced or even specific algorithms, but I'm using this as an example to state that what we are covering in this lecture is very basic. So in some sense, we can already encode, we can already write very precisely defined compression algorithms. When we talk about data on files, more generally, our files are organized in folders or directories. You can turn an entire folder into a file by creating an archive. It's actually tape archive or tar file now. Why is this so useful? Well, you can indeed archive files. You can use one of your computers and or one of your accounts at the university accounts. You have storage there as well. You can use that to archive certain information. So, for example, all your .py files that you have written already in this course, you can put them into one directory and archive them. After archiving them, you often also zip them, you compress them. And there is also indeed the zip program. We have the zip statement in the zip construction in Python, but there's also the zipping of folders. When we process files, we need to be mindful that how we are going to process the files, either as text or as bytes. And we need to decide this before we open the files. So we can open the files as a pure text file with the encoding UTF-8, or we can open as a binary file. We give them the separate mode B, uh, in addition to what we do with it, reading or something more. There is an important difference between the two. When we open as a text file, then everything that we read comes in as a string, and we can manipulate strings already very easily. When we open as a binary file, not specifying any encoding, then everything that we read, and we typically then read sequences of bytes, then we must decode the sequence of bytes, also using this UTF-8 as an argument of the decode method that is applied on the bytes. Bytes, by the way, is something that we encountered already as the output of the bin command or the hex command when we converted numbers in decimal format into byte strings, which were zeros or ones or hexadecimal letters. Now, everything is a byte sequence of bytes when we open a file for binary. Everything that we write must also be encoded as a sequence of files. So we go from a string to a sequence of bytes using again this UTF-8 standard for encoding Unicode characters. Unicode, which is a more general and more extensive form to write characters, more extensive than the ASCII code. So it's important, the distinction between a text and a binary file. So here I'm defining it, what it means as a programmer. We will also make the distinction whether we work binary or text. So whether we process character by character or line by line. For text files, we can do both. Binary files are typically processed either in batches of bytes or byte per byte. Okay, this lecture was originally designed from a sequence of Python scripts. So I had some problems in mind that I wanted to solve. And then in earlier versions of the lecture, everything was dumped on a file, on slides. And this is somehow a remnant of this, but this is useful to define what I mean by format conversions. So we can manage our library with plain text, with plain text files. So we did this in the previous lecture, where we needed a layer between the logical representation of a book, whether a book is available or not, its number, its unique index, and then the title. So that was good to motivate the functional modular decomposition of programs. Modules group functions that are dealing with the same type of problem. Here, the storing of the formatting of the information as data strings. Now, if you are a Python programmer and you know that the data will be processed by a Python program, then you may as well use data structures that are immediately recognizable by Python, such as a list or a dictionary. So these are two alternative representations of the same data. And Python scripts are very useful to convert from one format into the next. So this is another a very good application of Python scripts. It's another good application of processing files line per line. Here is the algorithm described in a flowchart. So you recognize the diamond of the text, of the test. So we have a loop. So flowcharts are very good at expressing loops. That's why I like them here. Um, when the test is true, so we have an empty string, and this happens when we are at the end of the file. So we read line by line, and when do we stop reading? Well, we stop reading when we encounter the empty string. Now, if a text is line oriented and there is a blank line, what is that not the empty string? No, it contains the new line symbol. So blank lines are showing up for us as blank lines in a line separated, properly formatted text file, but there will be something there. There will be a new line symbol. Okay, so this is also the algorithm to convert from one format into the next, taking an input file and for opening up for reading, and then opening up the output file for writing. So we compute another representation for the input and write that other representation to the output file. So the flowchart expresses the essentials of this format conversion algorithm. It's also in Python a very good illustration for the need of the break. While true, if the line that we read is empty, then we will break out of the loop. Here is the second conversion, a repetition of the same idea. We read line by line. We convert the list from a string. We read in strings. We convert to a list. We convert to a dictionary. Okay. Processing files character by character. If we have a text in a file, we may want to encrypt it. Encryption is a little bit a heavy word here. It's more scrambling it. It's not a good encryption because you still see, as we are replacing only the vowels, you still see the structure of the text. But the same idea holds. So if you want to use a substitution cipher, then you will use a dictionary. The values in the dictionary are the letters by which you replace the letters that are the keys. Um, so we will read the text character by character, and wherever we have a vowel, what is a vowel is that there is a key that corresponds to the letter in the dictionary. Whenever that happens, we replace it. So in some sense, this is session 9 in the beginning of the 4th week, in the week where we have our review and our midterm exam. This is kind of where several things come together. It's also a great illustration of the data structure that is a dictionary. The scrambling algorithm is defined in this flowchart here. We will open an input file for reading, open an output file for writing, initializing a cipher, the dictionary here. We read character by character. If the character that we read is empty, so now we really didn't read anything, then we are at the end of a file. So that's another way where the end of the file is detected. By the way, if you count the characters um, on a file, that's the algorithm that you would use as well. So each time when you encounter a new character that is not empty, you increase the character. Leaving off the dictionary test here, it would also be the algorithm on how you copy a text character by character. Um, but this is another good illustration of an if test sitting into a loop, although we have already the if break test here. So if we don't break out this, we continue and we do the test on the character if it is a vowel or not, which means that if it is in the list of keys, which is simply expressed by this in test here. All right, a more advanced application. So why do we want ever to process a file byte by byte? Well, in a byte opened file, we can move backwards. So files are a little bit like tapes. They are sequentially organized. So it's like when you listen to an audio tape, or when you see these movies, these video reels, you actually see a movie from the beginning to the end in one flowing sequence. But you can rewind the tape. Also, here we can reset the current position of the file 2, 3 spaces below. Why do we want to do this? Well, here is the application. We have the sequence of letters THE, that the word that we want to replace by another word. So this is transforming a text. A little bit more advanced application than the scrambling of the vowels. In order to do this, we only see one letter at a time when we read character by character, or here byte by byte. What we need to do is we need to maintain a buffer. So each time in this buffer, we maintain 3 characters, the last 3 characters that are read, replacing the last character, or not replacing, so shifting all the characters in the buffer. So it's like a queue, a checkout queue in a store, where the new character is appended, the first character gets popped. And each time with a new letter, we compare the buffer. We compare whether our buffer equals the word that we're looking for. There are many things that are coming together here. Our buffer is stored as a list, and we modify the list with a tuple assignment. So it's important when to use dictionaries, when to use lists, when to use tuples, and how to use them. So an item assignment in a tuple is not possible. So we cannot represent, or we could, but then we need to representing the buffer as a tuple is possible, but then you make a new tuple every time. That is possible. But it's better to use a list here. All right. I was mentioning binary files. So you need to open a file in binary mode if you want to move the cursor forward or backward from the current position. If you open a file in binary, then everything that you read from that file is a sequence of bytes, and you must be decoding it in order to get a string that you can read. If you want to write a string to a file, then you must encode the string, also with another method, and also passing that UTF-8 string. Okay, the purpose of programming is to write programs, and in this lecture I'm actually showing slides, and now I'm going to a Jupyter notebook. When I designed the lecture, I was writing scripts. So one can, and in some sense we have arrived at what you might consider the most important part of the lecture, that's the exercises. So you could look at the description of the exercises and see if you understand it. Go forward looking at the scripts that are posted, or if things are not clear, look at the Jupyter notebook. Look at the explanations, either also via this recording or in the explanations that are on the slides or that are on the pre-recording or are in the text in the markdown cells of the notebook. Okay, in this lecture we work with very small files. In the next lecture we go to the internet, but this is already a transition point. If you think of data, you can think of books, literal books. So there is the project Gutenberg that takes documents in the standard, in the public domain. So here the classic works of literature. You can download the plays, for example, the play Macbeth, and you can, so that's what the exercise asks for. Download from that website, download this text, and look for the number of occurrences of the strings Macbeth and Lady Macbeth. Um, this could give you a way for any text that you download, kind of, if you go past the common words of English, of course you will see lots of occurrences of the word the again. But you can also try to figure out what the book is about just by looking at the occurrences of certain words. Now, this is if you're literature minded. If you're more numerical and business oriented, then you could look for comma separated value files, looking at the stock value of IBM. So you can download comma separated files for the historical evolution of the stocks of a certainly publicly traded companies, such as IBM. So this is the processing of comma separated value files, where you can read the files line by line and extract the values comma after comma. Okay, let me go now to the Jupyter notebook. So the first section illustrates in two code cells, and in some sense a Jupyter notebook is not really used to view scripts or view statements all at once, but here I can illustrate it nevertheless for demonstrating the similarities and the differences between working line by line or byte by byte. So for this Jupyter notebook to work properly, there needs to be this file books available that contains these two lines. You can make up your own books.txt, but when you open up this Jupyter notebook, don't run it unless you have already the files. You can copy and paste from the markdown cells the contents. Okay, so to open a file, we use this keyword width. So width is not a good name for a variable, it is reserved. Lib will be the name of the file object. It's kind of the interface between the programmer, us, and the actual data on file. Through this lib name, so it's a variable, you can name it whatever you want, but it is obtained as the result of an opening. Here we open the text file for reading, so it's not because it is txt that it will be automatically considered as a binary file. No, it is the encoding that is very important, UTF-8. That is recommended. Although I think that the default, if you leave it off, it will probably mean that it is suitable for text processing. So we read line by line, and here I print every line without printing an extra new line. So if we would read all the lines, you would actually see that the strings, the last character of every string is this new line symbol. So by suppressing the new line in the print, I'm avoiding the white lines that would be seen. So I'm going to open the same file again. So we close after opening. So I'm opening again, but now as a binary. You do not specify the UTF-8 encoding here. Binary means that this is not possible. You don't open a file with this encoding. We open for reading and as a binary file, but then everything that we read is a byte. And to use the letter or to get a letter here, so the letter and the line is different here. So here it is a string, but here the line is essentially also a string. So in Python, whether you have a character or whether you have a string, it's all the same, which is very convenient. So but the point is that a sequence of byte must be decoded. You must apply the method decode to this to get a string. So these are the similarities are the while true and the break. We close the file. The differences are in the use of the UTF-8. So that's the first important thing that I want to show with this Jupyter notebook. Then we can decide to process line by line. So here you see the format conversion going from the ad hoc format. So here it's good that I have the ad hoc format. So here you see on top the two lines. What you see are the lines that store the information separated by the colons. So this is not really common. You would use a comma instead, typically. But I want to store this now as a list because we're going to use a Python program to process and to manipulate this information anyway. So list is more convenient. So before I rewrite, I'm not going to rewrite the file, before I write another file, I'm going to test first what it is that I'm going to make. I'm going to, for every line, I'm going to make a list where the first item in that list will be a Boolean, whether the book is available or not, whether then the second item is an integer, and then I have the title of the book stored as a string. So notice everything is a string in the end. So it comes in as a string, separated by these colons here. When I split a string, so it is a line, I'm getting data back. Data is now a list. First item is at position 0. I turn it into a Boolean comparing whether it is 1 or not. So I have, from the very beginning, I have a 0. It's not a 1, so I will get a false. So I'm printing just the list. And the printing here is very similar to the string representation. So the string representation is what is written to file, appended with a new line. Okay, so the Jupyter notebook is very useful to see the step-by-step build-up of the code. So I'm starting with something that writes to the output here. Here the output is now written to another file, opened for writing, opened as this encoding UTF-8. So, and I call this my new library. So the new lib is just the name of the file object used for the writing, used also in the closing. And I have a different file name. So there are the file names, the modes, and then the names of the variables that refer to the actual data on file. At the end here of what you see on this screen, you see the fast writing. So what you see here is the output as it is represented via the output of read lines. So here you can verify the strings. So we have a list of strings, so the double quotes, and every string, the last character is a new line. So even if you would write an empty line, it would just be, it would still contain that new line. Okay, we're not done yet, so I want to check now. So if I want to go to the dictionary representation from the list representation, I must take every string representation and convert it into a proper list. I can do this with the eval, but the eval is too general. So the recommendation is to do this with the literal underscore eval, which literally parses the string representation to whatever is recognized as the corresponding object. So here on the example, I import from the AST module the literals underscore eval. I have a list, just an example of a list. Uh, you see that this is a string. If I do the literal eval on this string, I get a list back. So we do have a list. So this literal eval is imported and it is executed. So each time here, so we have now we verify that on this new file that I made, that I indeed see the representation of the books as a sequence, as a line by line on file. I do have a string representation of a list. So explicitly it is of the class list. In the second half of this course, we will define this much more precisely, what classes are. Okay, I'm half hour in this pre-recording. I'm now at the middle of this Jupyter notebook. So I should probably say that this corresponds to some scripts that I have prepared. So here you see the script that was actually written when the lecture was designed at the start. So we want to get rid of this very strange format, the strings with the columns. Instead, I want to go to a list representation. And here is the script that does this. The same what we had in the Jupyter notebook. What is not in the Jupyter notebook is the subsequent transformation from the lines of the lists. I go to a lines of dictionaries. And this is where the literal eval comes then. And then what is written to file is the string representation of a dictionary. And each dictionary that is written has the three keys: the availability of the book, the index of the book, which I call here also key, and the title of a book. Okay, let me continue scrolling through the Jupyter notebook. When we want to scramble the letters in a text, so here you see some text. Again, for this to work, you need to have something that is called some text. Again, if you open this Jupyter notebook, you can copy and paste everything that you see in the output cells. Well, here what you see in the output cells. So I have this code cell here to demonstrate what is on file. So I write the letters in the text character by character, letter by letter. I do not write the new lines. So there are new lines also here, but they are automatically copied. So this is also the template for copying from file to the output to an output cell. Um, so that's the file that we're going to use to scramble the vowels. So we have the vowels A, E, I, O, U, and we are going to replace those 5 vowels by other 5 vowels. And here is the code for this. What happens is that we use the same um, pattern. So this is done with copying and pasting. We have in one code cell code that works, and this code is then extended. For every letter that is not in the dictionary, we will copy the letter to the output. Otherwise, we will write the corresponding value after the dictionary lookup. So this is another good illustration of a dictionary. Notice also the syntax, the not. So this is equivalent to writing not letter in D, but that's kind of awkward English. Letter not in D, if letter not in D, it actually reads a lot better. Okay, so this is still an intermediate because I want to make a new file, a new text file. So I have code that works, so I can see it from the output. I can verify that the letter O was replaced by I. So I was replaced by O. That's what I want to say. O was replaced by A. So I'm going to write everything now instead of writing into an output cell. I'm going to write to an output file. The file name is code text. The encoding is again UTF-8 and it is open for writing. Inside the code, I'm referring to this output file as outfile. Outfile is the name of a variable that you choose yourself. It should be, of course, different from what you give it as the in file. Okay, and then here you see again the check. You see what actually has happened to the code text. All right, this is processing character by character. Suppose now that we want to replace words or that we want to count sequences of letters. Also, essentially processing a file where you would read it still character by character, but you would need to remember the sequences of last 3 letters that you have read. So in some sense, I told you that this lecture was developed starting from working Python scripts. So this function here, add to buffer, comes actually falling out of the sky a little bit, comes from that Python script that was written earlier. So I will explain what it does. So it takes in 2 arguments. The first argument is a list. The second argument is a letter. The letter gets appended, or it replaces the last position in the buffer. So there is a difference. If the buffer is full at 3 characters, we are shifting the characters in the buffer via a tuple assignment. So the last character is replaced by the new letter. The first character is replaced by the second character. And the second character is replaced by what was then the last character in the buffer. So the buffer is compared to the word we're looking for, the. So the lists are going to be the same, and the equal test works here. So we will count in this sentence, so I'm going to open the file for reading letter by letter, adding the letters to the buffer, and each time comparing the buffer to the word. Each time when there is a match, the counter initialized here to 0 will be incremented by 1. And this is how we count the number of sequences of the HE. We will also count when it occurs in then and there. So in some sense, as counting as words, it's not exactly right. So I leave it up to an exercise to fix this. All right, now it gets a little bit more technical, but also more important. I mentioned opening files as binary. So why would you ever want to do this? Well, if you want to replace words, if you want to modify words, modify files, without making a new file. You could always make a copy of the file and then add, delete, or replace. This is very versatile. But perhaps you may not want to do this. You may only want to locally. You may want to look for the first occurrence of a word and then replace that word. Here is how you can do it. So there are three important things. We must open the file in a binary mode, and we must be aware that everything that is read comes in as bytes, a bytes type. So I can so for and then the third important thing before I continue, everything that you want to write to that file has to be of type bytes. So you must convert your string into bytes. In some sense, we started out with a string type, and this could have been seen already as the most universal type, but actually it is not. Bytes, sequences of bytes are actually much more commonly used in transferring information. Okay, in this next code cell, I'm making a copy of the file. So this is because I'm going to change a text. And actually, I don't want that some text is always changed into another text. And then I can no longer look for the word the. Then I have to look for the word that I'm replacing it with. So in this text, I'm going to replace the by 1. So it doesn't make sense actually, um, but it's a good illustration to indicate how to open a file now as binary. The same file. So I'm going to open for reading and plus something more. So which means that I'm going to update it, and I'm going to open it as a binary file. So in the previous example where I started out with, in the first section of this Jupyter notebook, the plus was not there. The plus is there because I'm going to write. So I'm going to write the string 1 after converting the string 1 to bytes using this UTF-8. So every letter that is read is added to the buffer. If we have a match with the word the, then I'm going to wind back 3 bytes from the current position 1. I think by default, if you leave the 1 off, it's the current position. But you can set the cursor with seek in a binary open file, either from the beginning, which is 0, or either from the end. So modifying a file from the end also goes much faster. So you can immediately position yourself towards the end. Or you can start reading a file backwards. Looking at the tail, this is useful if you're looking for a file that is kind of incrementally. So you can look at incrementally being updated once in a while. You can always look at the last characters that were added to it. So this would be another application of the seek. You would immediately position yourself to the end of the file with the seek, and then 2 would be the position, and then you would go minus from there. All right, that's actually it for the Jupyter notebook. I have 5 minutes left to look at the corresponding Jupyter, uh, the corresponding Python files. So the Python files are posted. So there is the word count. I have documented in the strings what it is that this script is intended to do. Also what I intend to demonstrate with this script. So there are many things that come together. So we have the list, the tuple assignment, and then we also have the use of the buffer in the processing of a file that is being read character by character. So it is a text file. What is a little bit more general is that the user is prompted for the name. So that's the main difference here. And perhaps I should show at least, uh, I should at least run one script. So I have the word count. Actually, it's counting the word the, and the extension is of course some text one. There we go. So of course Python scripts are also text files. You can count the number of occurrences of the keywords. Is there a lot of branching in the Python script? That's an alternative application. So there is this word count. Then there is the word locate. So I mentioned the tel. The tel gives the current value of the cursor. So you can, with the tel, you can get an impression on the distribution of the words. So let me illustrate what happens if I run the word locate on the some text one. So that will give the positions of the occurrence of the. So it gives the character position of every start of the. So this is the script here. So you can see I take the current position and then I do -3 to go to the beginning of where we had the first letter. So after reading, the cursor is placed after the character. And there is this exercise, do not count the when it is in then or when it is in there. So you can check whether the letter, so you will only search if the next letter is actually a space. Or if you want to be a little bit more precise, if it is also a comma, or so if the next letter is in the list of separators. And the list of separators, you can declare this at the very beginning. A separator, what separates words, they are the spaces, there are the commas, there are the dots. And you can also have the exclamation point and the question mark. And then eventually the quotes as well, they could also count as separators in text. Okay, I'm at the end and I do not want to go over time. So processing of files is very important, as we will see in the next lecture, in the second half of this session that immediately follows this. If we understand how to process files, we can also directly read files available on the internet. And this makes for some interesting applications.